All right, here we go. Today we are going to be learning about how to graph sine and cosine. What we're going to be looking at is the generic sine and generic cosine functions. So, right before break, we graphed sine and cosine on graph paper using our unit circles. And a quick refresher of what that looks like. Sine was like this, based on the unit circle. So in general, what sine will do is it'll go up, down, and then back up. And that's all based on just following those y values around your unit circle. That is what one cycle of sine will look like. Whereas cosine, if you were to flip your paper over and take a look at it, cosine would start at the top, go down, and then back up. And it would kind of look like this. Now we got cosine is we just followed those x values around our unit circle. Why we're going over the generic sine and cosine again is because we're going to be using these to help us graph sine and cosine. So what do we know about sine and cosine? Sine and cosine are periodic functions, which basically means they repeat forever. So if we were to keep drawing this and extending this, it would just repeat that cycle forever, where it would go up, down, up, down, up, down, and so on. Same with cosine. It's that same exact idea. These extend on forever. How I think of it, it's kind of like that heartbeat monitor. If you were to look at it in a hospital, how it would go up and just kind of repeat. Another good example would be radio waves, because they kind of just keep going up, down, up, down, up, down. Okay? So within that, there are two big vocabulary words associated. We have the period, which basically means how long it takes for sine or cosine, or really any trig function, to repeat itself. So what we drew when we created our sine and cosine graphs is we drew one cycle of sine. So this is what sine will look like before it starts to repeat. Anything after this point, it'll just be repeating again. Same here with cosine. We drew one cycle of cosine. So anything after that point, it would just repeat. What do we know about periods in general? Periods are 2 pi long. Why is that? It's because it is just one trip around the unit circle. And we know that 360 degrees is 2 pi radians, which is just one trip around the circle. So anything after that, you're just going around the circle again, which is why you'd be repeating. Then we have amplitude. Amplitude is how high or low we go in the sine and cosine function. So how high or low we go. In general, amplitudes are going to be 1 based on the unit circle. Why is that? It's because we know the radius of the unit circle is 1. The difference between the unit circle and what we're going to be doing with graphing sine and cosine is that we're going to be changing the amplitude and the period of the functions, which will create us to have to graph them a little bit differently, really by creating different scales. So how does this work? The generic sine and cosine function can be seen here, where y equals a sine b, in parentheses, x minus h plus k. Everything you see here is very similar to what they've been all year. H is a vertical shift, but counterintuitively. So what does that mean? H is going to shift it left to right, but backwards, where k is going to shift it up and down. If I'm going to be transparent about h and k, you're not going to use h and k this year. That is something your pre-calc teachers will work with you on. Really, our foundation for graphing sine and cosine is I want us familiar with A in amplitude and what amplitude does, and then what B is. B is a notation that is associated with period. We know that 2 pi over B is equal to the period, which we'll learn more about in the next slide. So let's go ahead and let's do some examples. Example 1 asks us to find the amplitude, period, and the equation. So first off, let's start with the amplitude. We know amplitude is how high or low our function goes. So we can see here that our amplitude goes up to 0.5. So we know that our amplitude is 1/2. And then we know the definition of period is how long it takes for sine to repeat itself, or how long it takes for cosine to repeat itself. So if we look here, we know that the general sine wave goes up, down, and back up. So we know that this is going to go from here to here. That is one cycle of sine. We could also go from this back point right here, up, down, and back to the center, and that was also one cycle of sine. So you have 1 cycle of sine, 2 cycles of sine. For period, we're looking for the distance of 1 cycle. So for us, we're looking for from this origin point right here to where the cycle ends or starts to repeat itself, which is 2 pi. In terms of the equation, what we are looking to use is we're looking to use our generic equation, which is y equals a sine bx. We're not going to be using a phase shift, so h or k. So what that means for us is that sine waves and cosine waves will be different from each other, when in reality, sine and cosine waves can really be the same thing with a phase shift, so a shift left or right. So for us this year, what does that mean? That means sine waves are going to start at the origin, and then they're going to go up, down, back up, or down, back, and back up, and cosine waves will start at the amplitude. So how are you going to tell the difference between a sine function and a cosine function? Sine functions are going to be starting at the origin, whereas cosine functions, you're going to be starting at one of the amplitude points. Like I said, though, I want you to be mindful of that. In pre-calc, you can make any sine wave become a cosine wave with a phase shift. That's just not going to be something we introduced this year. So keep it simple. Origin, if it goes through the origin, it's sine. If it doesn't, it's going to be cosine. So what does that mean for us? We are working with sine here. So we know it is y equals a sine bx. However, we know that a is our amplitude. And we found our amplitude earlier. We said our amplitude was 1/2, because that's how high our function went. It went up to 0.5, which is 1/2. Then we're working with sine here. We know it's sine because it goes through the origin. And we also know it's positive sine, which makes this positive because we go from the origin up. If we went from the origin down, that would make us negative 1/2 sine, which you'll see later on. From here, we're going to work with b. B is not as simple as period, because we know that the period is equal to 2 pi over b. So what we're going to have in all sine or cosine functions is one of the following. We're either going to be given b and has to find period, or we're going to be given period and has to find b. And in this case, we know the period's 2 pi. So we know that 2 pi equals 2 pi over b. And then we need to solve this to find b. If you just kind of look at this, you probably can identify that b is going to be 1, because 2 pi divided by 1 is 2 pi. If we were to solve this algebraically, what would we be doing? We would be multiplying each side by b. The b's will cancel on the right. And then we'd get b times 2 pi equals 2 pi. Divide each side by 2 pi. 2 pi's would cancel on the left, and we'd get b equals 1. So really, what are we going to have? We're going to have y equals 1/2 sine 1x, but we don't need the 1 in front of x, because 1 times anything is just x. So that would be our function here. Moving right along, let's go to this next one. Oh, I didn't erase my notes from earlier. Oops. Well, that kind of gave it away. What you're going to notice here is that our function here doesn't go through the origin. So for us, that symbolizes that this is going to be a cosine function. And then for cosine, we know how we can identify one cycle of cosine is by going from the highest point to the highest point and finding that distance, or we can go from the lowest point to the lowest point and finding that distance. So for us, we can't see a lowest point to lowest point. We can only see a highest point to highest point. So we know it's going to be from this highest point right here, which is 2 pi, to this other highest point up here, which is negative 2 pi. And then what we need to do is we then need to figure out the distance from negative 2 pi to 2 pi, which we could tell was 4 pi. So we know that the period is 4 pi, and we know that amplitude is simply just how low or high our function goes. So our amplitude here would be 1.5 or 3/2, Why I'm doing that is because we're about to get to the equation, and I like to keep it consistent. I don't like to use decimals and fractions in the same question, and this will just give us some options to see if we're going to use fractions or decimals. So we are at the point where we're going to write the equation. So y equals, and then it's a sine b of x. We can also use that as cosine, which we're going to do in this equation because we're working with cosine. We know amplitude was 1.5, and then cosine. But on this one, there's a catch. We know traditional cosine functions would start from the amplitude on the high end, or the positive side. So for us, that would be up here. Our cosine function doesn't. It starts below the x-axis in the negative function. What that means is it's gonna make the amplitude, or I guess the a value, not the amplitude, the a value negative. So negative 1.5 cosine. From here, we're going to use that same equation that we did last time. That period equals 2 pi over b. And we are either going to solve for period or 2 pi. In this case, we have period, so we're going to be solving for b. So 4 pi equals 2 pi over b. We're going to solve for b. We're going to multiply by b. B times 4 pi equals 2 pi. Divide each side by 4 pi. B equals 1/2. So this will be 1/2 x. However, like I just barely said a few seconds ago, I don't like using decimals and fractions, so I'm going to rewrite this so that it's consistent. We're going to say y equals, I'm going to call it negative 3 over 2x, not x, sorry, cosine 1/2 x, just so that it's consistent with fractions and decimals, etc. So that's really the first half of sine and cosine. If you want, I recommend you pause this video and go try the first half of the practice problems. The first half of the practice problems are where I'm going to give you a graph and then ask you to find the equation by using the amplitude and period. And that'll just get you familiar with those types of problems. When you come back, you're going to be looking at how to graph, which we'll do right now. So if you haven't paused the video and you're gonna go try those problems, I would pause now. So if you paused, welcome back. If not, well, we're still here. In these problems, we're gonna be asked to graph certain functions. With these types of problems, our first step is we're going to identify the amplitude, which we're going to abbreviate to amp. We know the amplitude is just 3, so that's just how high or low we're going to be going. So amplitude of 3, and then we're going to find the period. But this time, we aren't given the period. We know period is equal to 2 pi over b, and in this case, we are given b, which we know is 2. So we're going to plug in 2. So period equals 2 pi over 2, which then means period equals pi. From there, we need to graph this. So what am I really looking for? What do I really care about? I care that the period is representative of what the sine function should be doing. So what do I mean by that? We should see one full cycle of sine that is a distance of pi radians long. In addition to that, we know the amplitude is 3. So we know that the amplitude, or our sine function, should be going 3 units high. For consistency's sake, for us right now, for our unit, I like to keep my scales consistent. What do I mean by that? Whatever my period is, I'm going to divide it by 4, and then that'll be my scale for what I go up by. Why I'm doing that is because there's 4 important points when we graph a sine and cosine function, and this just allows us to see those points. So if I were to divide pi by 4, I would get pi over 4, and then 2 pi over 4 in this next column right here. However, we know that 2 pi over 4 is really 1/2 pi, or pi over 2. And then we're going to get 3 pi over 4, and then pi. Same thing on the other side, but it's going to be negative direction, negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. And for amplitude, I'm going to go up to 3 and down to negative 3. I want to be clear, your scale does not need to be the same as mine. What it needs to happen is that you need to just make sure that one cycle of sine is a distance of pi units long. So what does that mean for me? Because pi's here, I need to have one cycle of sine be to go from the origin to pi. If I said that pi was here, I would need to make sure that I go from the origin to pi for one cycle of sine. So what do I mean by that? We are going to plot a point. We know sine starts at the origin. And then there are 4 important points. Sine functions are going to go up to the amplitude at the first quadrant mark, so the first quarter mark. And then we go back down to the x-axis at the second quadrant mark. We go all the way down to the lower amplitude in the third quadrant mark, and then the fourth quadrant mark finishes the cycle of sine. So where we go up, down, and back up. And that would be one cycle of sine. Like I said, if your scale was different, that's totally fine. Just make sure that wherever you put pi, you can see one cycle of sine, because we know one cycle of sine needs to be pi radians long based on that being our period. So what does that mean for this other side here? We know that sine functions are cyclical, meaning that they repeat forever. So they would repeat forever to the right, going up and down, and forever to the left. So because I have space, I'm going to finish what this sine cycle would look like. I'm starting from the farthest to the left point, and I'm going to draw the 4 important points where we go up, down, to the lowest amplitude, and then back up. And then you would see that what we graphed here is really 2 cycles of sine, where we go up, down, back. That's one cycle, and then we repeat it again. And reminder, we're not going to have arrows here because arrows imply that we go up in the direction forever. So it would go up to the right forever and down to the left forever. That's not the case in sine functions. Sine functions repeat forever. So it would do the same up, down forever in both directions. And that's that example. We got our last example for this video. It's going to be a cosine function. It's going to be a very similar process throughout. Really, the only difference is how we're going to draw the cycle of cosine. So our first step is we're going to identify the amplitude. The amplitude is 1. Amplitudes are always positive. The signs in front just dictate the starting point. So for us, because this is negative, we're going to start at the lowest amplitude. If it was sine, that just means we'd start by going down instead of going up. So amplitude's 1, and then we know period equals 2 pi over b. And then we know b is 4. So period equals 2 pi over 4. Period equals pi over 2. So like I said before, I like to break up the period into 4 sections just so we can cover the 4 important points, but the scale doesn't matter as long as one full cycle of cosine is pi over 2 radians long. So for me, I'm going to say pi over 8, pi over 4. Why do we have pi over 4 there? Because it's really just 2 pi over 8. Then we have 3 pi over 8, and then 4 pi over 8, which is really pi over 2. Same thing on this negative side. Negative pi over 8, negative pi over 4, negative 3 pi over 8, and then negative pi over 2. From here, we know our cosine function has an amplitude of 1, so we're going to go up 1. I'm going to call this 1 here, negative 1 here, and now we're going to draw the cosine function. Cosine functions start at the amplitude. Because we are negative, we're going to start at the negative amplitude. So we're going to start here, And now we're going to graph a cosine function. Cosine functions go from peak to peak or from low point to low point. So high point to high point or low point to low point. So for us, we're going to go start at the bottom, go up, and then back down to the bottom. So we know we're going to end at pi over 2 and then at -1. And the same thing on the other side. So what does that mean in terms of breaking it up into force? We're going to cross the x-axis in the first chunk, hit the amplitude in the next, back to the x-axis, and then we're going to draw it smooth. And then same thing on this other side. X-axis, point, x-axis, draw smooth. And that's it. That's all the notes for sine and cosine. A lot of these functions are going to have the same concept. The biggest takeaways and biggest understandings so that you're as proficient as the rest of the class for pre-calc next year. If you have a solid understanding of amplitude and period, we're good to go. That's really the big takeaway from this unit. We want to know what amplitude and period means and what it means in relation to our sine and cosine functions. That's it. That's all I got for you today. Another video coming at you tomorrow. See ya.